Welcome back to the third day of KnowHow EdTech 2020. We're still fully online and free to all this year. If you want to engage with us and ask questions to the speakers, please feel free to do so on the live Q&A on the Nordic Edge conference platform. Again, today I'm Tobias Heiberg, and I'm still here in Copenhagen. And here with me will be Anita Schulbrede, who is indeed an expert on artificial intelligence. She's also the CEO and co-founder of Iris AI and faculty at Singularity University. In Stavanger, we've still got Andy Rhodes with me as the co-moderator, and he'll monitor any questions coming in from you who watch. As you know, Andrew is a strategic advisor on the National School Initiative at the technology provider Atea. He has more than 25 years of experience working with teachers with technology as a tool to improve and transform learning. As you know, we've set the topic for the session today as predictive learning. What predictive learning might be, our keynote speaker Atish Gonsalves soon will explain. But what's sure is that it has something to do with the use of artificial intelligence and big data for education. And that is exactly what we'll spend today's session looking into. But first, Anita, welcome to the studio. I'm so happy to have you with me here in Copenhagen.
It's a pleasure to be here.
To give a good ground for today's session, can you explain to us what is artificial intelligence?
Right, which is a very big question, right? Artificial intelligence is a big fluffy umbrella term that means a lot of things and nothing sometimes. But in short, right, there's 3 points that I think it's important to make. One is that there is a big difference between what we call superintelligence, general intelligence, and narrow intelligence when it comes to AI. And general intelligence is this idea of one machine that is as smart as a human being. And we're just not there yet. So what we're talking about all day today is narrow intelligence. So AIs that can do one thing and one thing only. That's important. Second important thing, usually when we talk about AI, it's software, right? So it's software that runs on some hardware, and there's a lot of data needed in that process. And that's the same as regular software. Usually the difference is explained as regular software works more like a calculator. You give it A plus B and you get C every time. It's pre-programmed to do that, while AI or machine learning software, it will learn from what it sees, what data it sees over time. So we said it works more like a human brain, which is a truth with modifications, because we don't really know what the human brain, how the human brain really works. So we can't really build machines that copy it yet. But it is a machine that learns over time and adapts. The third thing that I think is really important to keep in mind is that artificial intelligence is not this like, new magical fairy dust. This is science. It's a scientific field that is, 70 plus years old. As an example, neural networks were invented the first time or proposed in 1958. So it's an old field. It sees progress. It's gone through some winters and some springs and some summers. And right now we're seeing kind of a big, what's called a deep learning, let's call it a revolution, where we're seeing a lot of breakthroughs. So it's an ongoing scientific field, and it will keep being an ongoing scientific field, not magical fairy dust.
So not magical fairy dust,
No.
as I thought. Thank you for the explanation. And at least for me, I think it's a perfect frame for today's topic. You will be here with me all day.
Yes.
Through the session, kind of wrapping up the different segments, and of course also the session at the end of the day.
Yes.
Looking forward to it. Thank you. I hope I got it now with the AI, because now we are going to watch something that, for me at least, will be pretty hard to comprehend. Please have a look at this.
Me apasiona el fútbol. El equipo que llevo en mi corazón es el Liverpool. Nunca caminarás solo.
Ich liebe Fußball und die Mannschaft meines Herzens ist Liverpool. Du gehst nie allein.
J'aime le foot et mon équipe préférée est Liverpool, tu ne marcheras jamais seul.
Yeah, you'll never walk alone. Hi, Victor. Victor Riparbelli is the CEO and co-founder of the London-based company Synthesia. What we just saw in the video, at least I think, Victor, was me. But it concerns me a lot that I suddenly speak a lot of languages and that I'm a Liverpool supporter, apparently. I'm usually a fan of Manchester United and have been so since Ole Gunnar Solskjaer and Peter Schmeichel and Ronny Johnsen. How is this possible, Victor, and should I be concerned in any way?
Well, so what you just saw here was an AI version of you, right? So what happened was that we took the footage of you that you kind of recorded for the purpose. And with that footage, we can actually teach an AI system to sort of replicate you in a digital way, right? And the big change is that you've probably tried emojis or like these kind of more computer graphics looking avatars over the last 10 years, but actually deep learning and neural networks has allowed us to do this in a super photorealistic way. So that's the kind of technology behind this. And really what's happening here is that media production, as we know it today, which is something you like, generally speaking, you record it with a camera, or you record it with a microphone, is going to be something we can now program with computers. And that's going to mean that producing video content for educational purposes, for example, is going to be exponentially faster and easier than it has ever been before. So it unlocks the possibility to create these types of videos of educators, for example, where, just the kind of normal production way of recording with a camera, post-production, then you have something, that's going to be a lot easier, but also allows for some incredibly advanced opportunities in personalization, for example, where we can kind of try and replicate the one-on-one style of learning that you have with someone in a classroom, for example, and do that in a scalable manner.
There's no doubt in my mind that this has a huge potential when it comes to education, but it's also kind of scary at least for me to see. But I guess you're going to tell us more about it right now, Victor.
Yeah, thanks. Yeah, so great to meet everyone virtually. I'm Victor, and I'm the CEO and co-founder of Synthesia. We're a London-based company developing AI technology for what we think of as video synthesis, which really is going to be the next sort of major leap in how we produce media content. Before I go into like what we do and how it works and why it's really valuable, just a quick message from my own AI presenter, Anna. I'll just play this video, and I'll hope that it looks somewhat in sync.
Hi, and welcome to the EdTech conference. I'm Anna, and I am an AI presenter created. Hi, and welcome to the EdTech conference. I'm Anna, and I am an AI presenter created by Synthesia. This video was created by simply typing in text. Today, Victor will talk you through how to scale your production of training videos and communicate more effectively and in any language. Please meet Victor, and I will check back in shortly.
Yeah, so thank you to Anna for giving me another introduction, even though you did it very well, Tobias. As you can probably tell, this was not a real video. I actually created this video just a few minutes before going on to this conference by simply typing in text. And that's what I'm going to be talking a little bit more about today. A very high level in the company. So we originate from Stanford and UCL. We're a bunch of mostly PhDs and professors. We're trying to solve some of the hardest problems in AI and deep learning. And the reason we're doing this is to make it much easier for people to create video content. We've built a platform for educators and trainers, that's what it's mostly used for today, that allows you to very simply go in and create these kind of presenter style videos by just typing in text. So I'll show you how that works in a second. But fundamentally, we have these AI presenters. Tobias was just one before, and it's around a 5-minute recording process to become one yourself. And once you've created this like digital replica of yourself, the way it works is that you simply just jump into the platform and you start creating content. So if I'm going to show you how you would create a kind of usual educator style video, what you're seeing right now is what the product actually looks like. We have a bunch of actors in here. We have a set of actors that come with the platform. So they're kind of built in and you can create content with them straight away. You can also, as I mentioned before, you can upload yourself so that you can become one yourself. Once you've selected your actor, you simply jump into the video creation pane here. And then you simply just start typing in your lecture or your content, whatever that might be, which is really easy, right? So if I say, hello, this is a test, the system will then determine that I'm speaking English. I can select different voices. But one of the really important parts of this system is the ability to do this in more than 50 languages. So if I type in Danish, which is where I'm from originally, the system will detect that I'm now typing in Danish, and it will simply just render out the video in that language. So you can imagine the potential to take, just master versions in English, just translating text script, putting them back into the system into different languages. And all of a sudden, if you're a big corporation or if you're an educational institute, you can actually offer your content in many, many different languages. Once I put in my text, I can export it as a green screen, use it as normal video editing software. I can put in my own background. Lots of people use this for PowerPoints, for example. I can resize my actor and do a kind of a circle-based look like this. And you have lots of possibilities to edit your video. So that's kind of how the system works. It takes around 5 to 10 minutes to create a video. Once I click create video up here in the corner, and then your video will be ready, and it'll be a video like any other video that you know of. So not only is this a quite amazing way to sort of speed up your production and also make it a lot more affordable, it also offers some really interesting extra possibilities that I think, especially in education, is quite interesting. One of the customers that we work with is WPP, the world's largest advertising conglomerate. And they recently rolled out a course for more than 100,000 people worldwide. So they have lots of agencies around the world. What they wanted to do was they wanted to upskill their workforce in digital transformation and how some of the new ad platforms that are coming out works. And they wanted to do so in a really engaging way. So first of all, this kind of course was actually created entirely on the Sudisia platform. You can see that Anna over here is the presenter I used before. But also each course is personalized to every single employee. So when you go in to take this course, we know what your name is, your role, which agency you work in, the city you're based in, the language that you speak, and you'll get the course in your own language. But the presenter will also know something about you, and that will affect which video that you're watching. So if you are director level, for example, you'll get different information than if you are someone who is more kind of practical in their work, and so on. So this is really interesting how you can sort of take one video course and actually create 100,000 different versions of it. And it's super scalable because everything here is just code. There's no need for using cameras or microphones to record things. You simply input text into the system and it gets out with these videos. So just a few examples that might also be interesting for education. Video production is kind of what we do mainly. We're rolling out some software for producing visual chatbots very soon. This example should speak for itself, but I think getting into the classroom and making more one-to-one type of experiences using these kind of virtual teachers is a really interesting concept. So have a quick look at this video.
What will be the output of this code? I get your point, but remember enumerate takes a list and returns tuples. Awesome.
So as you can see, what happens here is that based on what the learner does on the platform, they will get feedback tailored to that. It obviously depends a little bit about what you're learning and what your learning style is. We've done some work, especially with kids, where this type of learning just makes it much more engaging than just having someone sort of talk to you repeatedly. So this is one of the sort of big promises of these types of technologies, making video a much more interactive experience. Another thing that's really great about these technologies is because video is now a kind of dynamic asset, you can update it continuously. So lots of the customers we work with has sort of been a little bit on the back end on producing high production quality video content before, because it might take you 3 months to actually execute the full production. And then once your production is done, there's a new policy or there's a new regulation, and all of a sudden your video content is void. With these types of solutions, you just take out the video that you built before, go in, change the script, edit it out, and then you have an updated video that talks about whatever is the most relevant for your business right now. So it offers a much easier and simpler workflow to keep your content up to date. We work with lots of big companies. You can ping us if you're interested in learning more. And I would also urge you to jump on our website and try creating a video for yourself. It takes 5 minutes. Just go to the front page here, click create an AI video, put in your own script, and we will get back to you with that video, usually in a couple of hours, but we're getting a lot of traffic at the moment, so bear with us if it takes a little bit longer. Thanks a lot, everyone, and hope to see you create a video soon.
Thank you so much, Victor, for this interesting presentation. To me, this is the future already being here right now. Anita, what do you think of this?
I mean, I think it's deeply fascinating. And it is, I mean, as we talked about earlier, this like deep learning revolution is what is enabling this. And Victor, great work. I'm curious to one thing though. I mean, we had Tobias here, become a Liverpool supporter.
Yeah, it could go even worse. That could be a Brøndby supporter all of a sudden.
True, yeah. and I'm personally okay with this. But what if we turned him into, say, a fascist and had him, say a bunch of things that wasn't okay? Like, what ethical considerations do you have to make as you're building this?
Yeah, I mean, that's obviously what springs to a lot of people's minds when they see these kind of technologies, right? And there certainly is a potential misuse in these. I think it's important that we see this kind of technology as a kind of natural evolution of all the things that has happened in media over the last 20 years. We have the same issues today with people creating text content that we don't like or image content that we don't like. Photoshop has been around since 1991. In many ways, it's kind of an expansion of that, right? For us, I see this as being like a two-pronged approach. For us, we have lots of content moderation in-house. So every content, like obviously we block, outright hate speech content. That's kind of easy to do with filters. We can do that much harsher than a social media network can do, for example. But also we flag content that is political by nature, and we, have kind of guidelines around what we offer. But I think the more important piece of this is that we, kind of educate people that this is now a possibility, that we are more skeptical of video content that we see. And there's also a lot of good work done, and this is a very long topic, on people building systems for detection, but I think more importantly, verifying who is the sender of this particular content. That's something we're also working on.
Victor, thank you so much for showing us this cutting edge technology, which of course holds huge potentials when it comes to both business and education, but of course also some ethical dilemmas in there that we're going to talk about more also today. Thank you so much, Victor.
Thanks, guys.
We'll hear from Atish Gonsalves, who was the person who actually introduced us to the predictive learning. Atish spoke to us also yesterday about social gaming and his London-based company Gamification. Previously, Atish has been engaged by international humanitarian aid organizations, including the United Nations. And today he'll talk to us about how educational technologies, big data, and artificial intelligence is applied not only to deliver targeted education in remote and underdeveloped regions, but also to predict needs for critical knowledge. Here is Atish on predictive learning. Welcome back, Atish.
Thanks, Tobias, and thanks, KnowHow EdTech, for having me back. So yeah, greetings from London. Let me bring up my presentation. So as Tobias said, I'll talk a bit about sort of predictive learning and a bit more broadly about some innovations in learning that I was leading on in a humanitarian organization. So a lot of the examples I want to give to you are from humanitarian contexts. But I'll start a bit first with sort of looking at sort of what are some of these broader learning trends that we're seeing. So over the last few years, we've seen quite a few sort of trends around modularization, around nano degrees, around immersive learning, including virtual reality. I talked yesterday about game-based learning and artificial intelligence now in education, like from the last presentation. So my examples I'll share now are not just AI by themselves, but how AI is also mashing up with some of these other technologies as well. So just as a very simple example, a few years ago in 2015, there was a Kickstarter around this toy called Cognitoys, which was sort of used for supporting education in classrooms, which was tapping into IBM Watson, Watson's AI. So kids were able to ask it questions. And that technology has now matured over the last even 5 years. You've got toys now like Roybe, which is doing very similar things, just teaching kids STEM and languages. So the point here is that this stuff is now starting to mature a bit, that it's easier and cheaper for manufacturers, for education sort of providers to tap into this type of technology. And we started to look at this kind of concept and say, okay, how could we apply this as well in the humanitarian space? So previously I was innovation director at the Humanitarian Leadership Academy, so from where I'm going to share a number of the examples. And at the end of my presentation, I'll also share some links with you so you can actually try out some of these examples yourself. So the Humanitarian Leadership Academy was responsible for setting up a global learning platform called Kaya Connect, which is open and accessible to anyone, targeting professional humanitarian aid workers, but also volunteers, so people who work, for example, for the Red Cross around the world. And it has a number of online learning courses. So it has self-guided learning, massive open online courses, reaching people in quite a wide range of countries. A large number of the users were coming from quite fragile sort of countries, or countries where there were active conflicts even going on. And the purpose was to sort of upskill, support them on everything from how do you lead a team in an emergency context, to protecting yourself, to doing sort of more sort of common things like project management and finance. So it's quite a wide range of skills. And so there are individuals who can go and access sort of these online learning courses, and organizations like the Norwegian Refugee Council or the International Rescue Committee or Save the Children are also using this as a organizational learning tool as well. But I think the challenge was that how could we push the boundary of sort of online learning from simply sort of the self-guided stuff to sort of more interactive, more engaging stuff. So what we started to do was look at, okay, what's a spectrum of EdTech innovation which is happening in the outside world, out of the humanitarian space, a scan for stuff which is happening in Silicon Valley, which is happening in other sort of EdTech spaces, and bring in sort of small sort of experiments, test them, experiment, and then where some of these innovations are being successful, then scale those through Kaya, which was the sort of the global sort of platform. So we were looking at EdTech innovations which had seen effectiveness in other spaces, had scope for integration somehow with the learning platform. And then we started by incrementally sort of developing low cost, low tech ones. So a lot of the innovations I'm going to talk about are not things just super expensive, just fairly easy to roll out. So hopefully also you see that you get inspired and you see, okay, we can actually implement, for example, chatbots. So the spectrum, in a sense, I mean, it obviously depends on the complexity with chatbots and with predictive learning, but I've sort of laid it out in an increasing level of complexity. So moving from simpler things to more complex things. So I'll start with chatbots. Chatbots have been around for quite a while. In the marketing space, you go onto a website and there's an annoying little thing which pops up and says, how can I help you? And we know that it's not a person. But we started to see now, how could we use that sort of technology in the learning space? And so we were looking at it from two perspectives. One was the Humanitarian Leadership Academy had quite an active following on social media, almost 1 million followers between Facebook and LinkedIn and Twitter. So we started to bring these chatbots through the social platforms to where the users were. And it allowed them to interact with these chatbots and ask it simple questions like, this is where I am currently. I'm a new volunteer based in this country. I'm interested in these kinds of topics. And then it would sort of make recommendations, not just for individual courses, but it would even craft up, let's say, a learning pathway for you. So we started with very simple chatbot engine. So there's an engine called Chat Fuel, which doesn't really use a lot of AI. But then we started to also experiment with Google's Dialogflow engine, which is really used more for marketing in marketing purposes. But we started to use it even for developing these sort of personalized learning journeys. And so again, with the link that I'll share at the end, you can actually try out some of these pathways and see how you are able to interact with these chatbots. But what is happening is that these engines are becoming more accessible, and you don't need to be too much of a developer as well to create these and integrate these into your learning environments. The second area I talked about yesterday, so I'm not going to go too much into it, but we started to look at game-based learning with a primary purpose of scaling human engagement. So we started to integrate game-based learning, which included human-to-human connection, and then integrate this into Kaya as another way of interacting. And then we started to also look at how can we make, particularly in the humanitarian context, how can you make people feel like they're actually in a crisis or in a certain country or in a certain context. So we started first with VR with really simple 360 video. So we started to work with sort of really good filmmakers and content creators in different places in the Philippines, in Lebanon. And we started to create these sort of very simple bite-sized 360 learning nuggets, which were then incorporated into learning pathways. But with the primary purpose there was to make the learners feel like they were really part or really immersed into an emergency. And then building on from 360 film, we started and then looking at interactive VR experiences. So one of the really interesting projects we worked on was called Safeguarding VR. So safeguarding is sort of the prevention of sexual exploitation and abuse. It's quite a difficult and quite a important subject, very sensitive. And here we were trying to train managers who were responding to someone who had come to them with a safeguarding incident and how they would respond to the survivor of that safeguarding incident in an empathetic way. So we worked with a partner called Body Swaps. They're also sort of based in London. And we looked at this sort of concept of body swapping where you are first observing an incident, then you are switching into first-person scenario, into first-person conversation with the survivor where they are speaking to you, but you respond then in your own voice. You then body swap into their character. Now you're seeing yourself originally as another virtual character. You hear your own voice back and you're able to self-assess. So you're hearing the way you responded to the survivor, but from their perspective. And where the artificial intelligence here is coming in is then we just did a integration with IBM Watson for natural language processing or NLP. So what it was doing was it was taking so the words that you also spoke, so you can already self-assess, but it also did a very simple semantic analysis, or it analyzed the words you'd use and try to pick up words that you shouldn't have used. For example, you should never ask a survivor of an incident like this, why were you in this situation? So it had some sort of good and bad words that you should have used. So you should have used the survivor's name at least a few times to sort of build empathy. You should not have used the word why. So using sort of this simple semantic analysis, you were able to give sort of some analytical feedback as well. So at the end of this experience, not only did you get sort of a really good self-assessment by watching yourself and responding, but also you got some AI-based analysis of the words that you had used in that experience. So the last piece, which I want to share, this is more, it's still early days of where sort of Kaya and the Humanitarian Leadership Academy is. But through the Kaya platform, we're generating a lot of data on learning history, on the courses people are doing in different regions, and being able to sort of look at, what sort of related courses people could be interested. So think of like Netflix of learning. So that sort of personalization and recommendation engines are starting to happen. But what I want to challenge you as well is to think about is the data points that you're looking at. So Anita was talking about like AI and machine learning. It's simply looking at patterns and making predictions based on these patterns. But thinking outside of the box, thinking outside of the learning engine itself, so we started looking at what other data is there. And we started looking at what humanitarian crisis data is there, what upcoming disaster data, so looking at climate models are there. So you start to mash up now the learning data together with other sort of operational or humanitarian data. And then you start to be in a position where you can make recommendations for someone who is in the Philippines, for example. So they have quite a regular typhoon season. So even before typhoon season, if the climate models are predicting quite a heavy typhoon season, it can then start making recommendations to you on Kaya Mobile saying, this year the typhoon season is going to be quite strong. So why don't you try out these disaster preparedness courses or these bite-sized sort of pieces to get people already ready before the disaster even strikes. So this is sort of the vision we've been starting to sort of look at, sort of different projects around this area. But my sort of key sort of message here is look outside of just the educational data you have and look at what other kind of data points as well you have available to you. My last point before I close is just to say is to look at all these wonderful, magical innovations, but don't forget the human angle as well to it. So whenever we've used sort of these technologies and we start to incorporate these into the design process, we've used human-centered or user-centered design thinking. We've involved users as part of the design process, run things like learning hackathons where we essentially bring people together who are at the front lines, who are working with these local NGOs or UN organizations or Red Cross, working with them to co-create these kinds of innovations. So don't do it top down, but very much work with your users. So in your case, it'll be work with the teachers, work with the students to co-create these solutions, and they'll be more effective. And then you can scale them up through platforms, but very much make sure to involve the user in the design process. And these are just some examples that we have from like workshops we've run in person last year in Jordan, but we've also run these now more increasingly virtually, especially during COVID. So I've got the link up here. I think the organizers are also going to post the link in the chat window. But thank you again for having me back to talk about this. And I've got my email address as well up there. So please do reach out to me if you have any questions. Thank you so much again for having me.
And Atish, a huge thank you from us as well for yet another talk today and the window to the amazing work that you do. And I guess also for putting the spotlight on human interaction and the human factor in this. Andrew, I guess we might have a question from you guys in Stavanger.
Yeah, I think this was really fascinating. And one of the questions I had was, why do you think this is so readily adopted in developing countries, but yet kind of, if you look at the kind of Western education and the kind of pandemic that we've been through, I mean, although many digital tools were used, they were kind of used at a very simple level. So why, Atish, do you think it's developing countries that are kind of adopting this kind of very forward-leaning technology?
Yeah, I think one of the reasons, and so you hear the sort of phrase leapfrogging happen sort of quite a bit, particularly in, let's say, on the African continent. There's been sort of quite a lot of leapfrogging, let's say, in terms of the technologies which were traditionally available, let's say, in terms of what could be used in the classroom, but the infrastructure just wasn't there to be able to use it. So they leapfrogged, for example, to using mobile learning very quickly there because they had no alternative. So sometimes in some contexts, the challenges to some extent drive the innovation, and there is no other alternative but to move towards some of these kinds of tools. So I would say that that's probably one of the reasons there's an openness to try these tools because of the constraints that are there in the first place.
So to kind of follow that question up then, what do we need to do to drive more innovation in Western education, do you think?
I think I think it was in my first slide there, is to sort of also be a bit pragmatic on these things. I think sometimes we do look at a lot of these weird and wonderful innovations and go, okay, this looks like science fiction. So I think my point there was sort of try the simpler stuff first, experiment with simpler things which have been tested, or try them as small experiments. They both are good ways to engage employees, engage teachers, engage people to try out new things, but also your risk is quite low there. So if you fail forward, you learn from that, and then you're able to experiment with something else. So I think I think the point there is, yeah, trying to sort of try small things, and then sort of using that innovation spiral where if it starts to be successful, then surely then scale it up. But I think that trying things in small, simple ways first is probably a good way to mainstream these innovations. Otherwise, if you go straight for trying to roll out robots to all students, or it's just not going to work. I mean, you need to start small.
Thanks.
Atish, I really like your comment on failing forward and the small steps, of course. Anita, do you have anything you want to ask Atish about?
I mean, I was going to continue on the same track of this. Like, I love the humanitarian approach in this. I love that this is being applied for some incredibly good causes. But a lot of tech is built, I mean, for obvious reasons, in a very capitalist structure. What are your experience with getting funding, getting resources for things that are incredibly important, but that might not have like a massive IPO exit at the end of the day?
Yeah. No, for someone who's leading what I call a social enterprise startup, it is definitely challenging. So I think traditionally the funding models for these came from grants. And so you see the humanitarian development sector sort of relying quite heavily on, let's say, government grant funding or international aid funding. But there is an increasing appetite also for social impact investment, for example. So can this stuff have a really positive social impact, but can it also have value in the private sector and make some money as well? So I think there is an investment, there is an interest in mixed investment models, so where you can get impact investors or traditional venture capital investors as well, together with grant funding. Because you're right that quite often these really wonderful projects go to a certain point, and then the funders get disinterested, and then the project dies, which is quite a pity as well. So I think having a sort of mixed model of funding can hopefully get more people interested in really interesting projects, but also it has a social, let's say, a social impact as well to society.
Atish, a huge thank you to you for participating both yesterday and today. Thank you.
Thanks so much for having me. Take care, everyone.
I hope that you now got an idea of how the more underlying properties of digital technology may be applied purposefully in education. In the next segment, we'll look at 3 cases that are very much different, from primary school to medical surgery. Still, they are all applied cases of advanced technology enhanced and adaptive learning, somehow relevant to many of us. First, we'll hear from Google and what they're doing on artificial intelligence in education. In the Nordics, Chromebooks and the Google platforms for education are widely adopted at primary schools. And that's why both teachers and parents should now pay attention to what Laura Holmes, who is a senior product manager at Google, will tell us. Laura has been at Google for almost 11 years, most recently working as a product lead for assistive learning. Laura has told us that she is super passionate about the possibilities of artificial intelligence in education to help learners be the best versions of themselves. Here is Laura.
Hi, KnowHow EdTech. Thank you so much for inviting me to chat with you all today. The last 6 months have been some of the strangest months in education. Schools across the world were shut down, and many transitioned to online-only instruction. Most students haven't been able to get the kind of education that they need, and many teachers had to completely reinvent the way that they teach. There's been a large shift across the globe to incorporating technology, or EdTech, into the classroom, and the coming months will tell us what is here to stay. As a product manager for assistive learning at Google, I've seen firsthand how some of our EdTech products have benefited teachers and students during these unprecedented times. Specifically, I work on projects that use artificial intelligence and machine learning to benefit learning outcomes, or AI and ML for short. AI and ML are terms that can often be confusing because AI and ML can apply to so many different contexts. In short, they're technologies that learn from data to do smart things, that ideally save people time or make things possible in new contexts. Google's mission is to organize the world's information and make it universally accessible and useful. AI is helping us do that in exciting new ways, solving problems for our users, our customers, and the world. I'm going to talk today about some of the ways Google is using AI and ML to do smart things in education, remove some of the mystery, and paint a bit of the future. There's been many attempts to incorporate AI into EdTech. For the dreamers, AI and ML allow us to imagine a world that is infinitely personalized and adaptive to an individual student's needs. For any of you who have read The Diamond Age, the protagonist's personalized book is instantly responsive to her learning context and guides her education towards a remarkable outcome. The world today is a little less magical, but we're just getting started. For instance, many companies have built systems that attempt to map a student's knowledge for the benefit of customized learning, but nothing has emerged as the de facto right implementation. Learning is complex and vast, and it takes more than data modeling to create a great educational tool. Applying AI to education requires thinking about student motivation and the complex ecosystem that the student is already a part of. In fact, a few years ago, I was working on a product known as Grasshopper, and we first experimented with an adaptive learning model. And while our model was reasonably good at determining a student's overall aptitude and next step, students needed more visual cues to feel a sense of progression, and our adaptive model ultimately failed to motivate students towards a successful outcome. As for some successes, I'd love to talk about how Google is approaching the intersection between AI and education. Let's start with a feature we call Originality reports in Google Classroom. For a teacher, detecting plagiarism was always a challenge. A student could be copying from a fellow student or from some book or website. That would require holding each assignment in the teacher's head, and then some awareness of external sources or knowledge that a student wouldn't stylistically write a certain way. That requires a huge amount of brain power. But what if we could offload some of that brain power using artificial intelligence? What if, rather than a teacher being responsible for understanding if there's duplication across 30 students' work, or if there's a reference to a book or a website in an unsighted way, a computer could scan papers for the teacher? That's what Google Classroom Originality Reports does. It looks at Google's body of knowledge across the web, and it also looks across its known set of student assignments and saves the teacher time and energy to understand if a student copied part of their assignment. Another example of how we use AI and ML for education is with an app called Socratic. This app is meant for students who get stuck doing homework. They can take a photo of their homework problem and instantly find concept explainers and similar problems to help students find their way, turning a possible moment of demotivation into a success. The application of artificial intelligence in this case might seem subtle compared to robots or other Hollywood conceptions of AI, but perhaps more useful. In the case of Socratic, we're pairing a couple of different technologies together: optical character recognition, or OCR for short, and translating a homework question into its conceptual pieces. OCR is a technology that recognizes the characters in a photo and translates those characters into text. It's a technology that has been around for a while, but the quality of OCR has been increasing. Where previously it could only handle printed characters in a subset of scenarios, now OCR can interpret handwriting and complex math equations. Once Socratic is able to understand the homework question in the problem, it then uses machine learning to understand the concept being asked about in the problem. For instance, if a problem references words like acceleration, then our systems know that the question is a physics problem, not a history problem. But taken one step further, if a problem is asking about how long it will take a motor to lift a piano 20 meters, our system has learned through machine learning that this type of problem is associated with similar problems that require knowledge of power, work, and weight to solve. As such, Socratic lets the student know that these are the concepts being used in the problem and shows them conceptual explainers. With these types of nudges, a student can solve the problem and similar problems in the future. The last example I'll talk about today is an early literacy app called Readalong. This app uses voice recognition and text-to-speech technology to give students a reading tutor in rural, low-literacy parts of the world. While you might have heard terms like voice recognition and text-to-speech before, these technologies are just specific applications of AI and ML. For instance, voice recognition uses machine learning to map a student's voice to other voice patterns it already knows, and those patterns map to words. Readalong then determines if a student's voice is correctly reading the story text, and then gives them reinforcing feedback. But before I get any deeper into Readalong, let me touch quickly on a concept that we try to keep top of mind when applying technology to solve educational problems. We need to make sure we solve real user needs. It's so easy when we encounter a new technology to try to shoehorn a solution to match a problem. I've personally found this strategy tempting at various points in my career. But when it comes to education, we need to stay grounded, and we need to make sure that we understand the unique circumstances of each student and teacher, since learning can be so personal and diverse. When it came to Readalong, the folks on my team who built it spent months trying to understand who their users really were. The app first launched in India, where many families might only have one phone that is shared between parents and children. And many of these phones don't have regular connectivity, or connectivity is expensive. The team took some of the existing technologies around voice recognition, which is the same technology that you might use to speak to Google Assistant, but developed offline versions that could be packaged up and used without a connection to the internet. This required significant modifications and simplifications, but met the constraints of what their users really needed. To date, Readalong readers have spent over 3 million hours reading stories in the app, and students see an improvement anywhere from 38% to 88% in their oral reading fluency after reading for 100 minutes in the app. It's these types of applications of artificial intelligence to education that truly excite me. Each of the applications I've mentioned save teachers time and help students when they might not have had another option. AI and ML have the opportunity to expand access to education in a way that hasn't been done before. Yet, as we design these systems, we need to keep a couple of principles in mind. We need to make sure that our solutions are pedagogically sound, and we also need to respect the teacher, since teachers are so fundamentally valuable to how students learn. That's why so many of our applications of AI and ML have been oriented towards organizing existing information for teachers and students to use, and trying to save everyone time. And our principles also encourage us to do impact studies, like what we've done with Readalong, that use educational evaluation to make sure the right things are actually happening. I hope these last few minutes have shared some of my excitement for how AI and ML can improve education and given you a glimpse into how these technologies might increase access to education for the world. Thank you.
Thank you so much, Laura, for presenting this. And of course, this undoubtedly holds a huge potential. Mm-hmm. But Anita, there's also a lot of dilemmas in there. Where do we have to be careful and aware if we don't want to kind of hand over education to big tech providers alone?
That's a good question.
A hard question, I guess.
It's a hard question, right? I mean, so a couple of the things first of all, we have to acknowledge that what she's talking about is it's amazing technology. It holds amazing potential, right? And a couple of the reasons why Google is able to do this is, of course, that they have access to such vast amounts of data, which we have to have, and a tiny little player coming into the marketplace isn't going to have access to that kind of data. So Google has that advantage, and so does, for example, China, with a lot of companies kind of interconnected into that ecosystem, right? So there's some big players that has all of that data. In addition, it should be mentioned that Google, and I say this a little tongue in cheek, but they might be one of the few companies in the world that doesn't have a research budget on AI. They just do all the research they can on AI. There's no limit to what they can do, which brings us to a point where they become a very, very, very powerful player. And there is a chance that they or some Chinese companies will be this kind of total winner of this AI race, which leaves the teachers, the end consumers in a place of somewhat vulnerability. You have to use their products and services. And of course, Google's had their "Don't be evil" slogan. And the question is, of course, do we trust that? Do we just leave it up to them to like solve this, or how do we do it? And there's no clear answer. And then, the EU is coming in with GDPR and, personal data regulations, and some of it is good and some of it is really just not working. But it's a massive, challenge. And one of the things, and in that whole discussion, suddenly we have other players like TikTok coming in. It's not a learning tool, but it's tools that every single kid that has access to a smartphone is using. And how do we, as parents or teachers or other people in their vicinity, how do we secure their privacy, and how do we secure that their data isn't being misused by organizations that has an incredible amount of information about them? So there's so many things to tackle in there that we have to kind of gobble at bit by bit, I think.
So these unique possibilities that we get also come with some very unique and hard questions to answer. And that's exactly why we're here. Not that we think that we can answer every one of them, but at least we can ask the questions.
Yes.
Great, thank you. With me again, maybe in the background, you can hear the clockwork from 1800s at the Carlsberg Brewery. That's kind of an audio signature that we've chosen for this conference. But next, we'll look at something completely different. Insiders, and indeed at the cutting edge of technology-enhanced learning. From Finland, Petteri Joenpolvi is CEO of Adesante, whose vision is nothing less than zero surgical failures. Petteri started his career in the 90s as a registered nurse in the cardio-intensive care unit. He has been working for several healthcare technology businesses, among them GE Healthcare internationally. For the last 2 years, Petteri has run the company Adesante that uses technologies like XR, AI, blockchain, 5G, computer vision, and more to develop their tools. Petteri will now tell us about Surgery Vision, which is their MRI, virtual reality flagship.
Thank you for this kind introduction. So like just mentioned, I'm Petteri Joenpolvi, the CEO of a company called Adesante. First of all, Adesante is a startup company established 3 years ago, roughly, and we are providing extended reality technology for the healthcare service providers. And now today we are focusing more on the surgery business, where this technology is getting more and more commonly used. But before going into any details, I would like to clarify and secure that we are all aligned with the terminology used during this presentation by going through these definitions. Like virtual reality itself, it is the technology where the user is totally integrated into the computer-generated world. So the surgeon, for example, cannot see nothing outside of the glasses, where the augmented reality presents the object or depicts the objects, virtual objects in the real world. And then the mixed reality is a kind of combination of those, where the different layers of the data is combined together, bringing the online side with those virtual objects into the one view, and the extended reality covers all these free technologies all together. But to be honest, when speaking about extended reality, there are still some barriers or restrictions why the technology is not that widely used in the surgery or in healthcare technology in overall. Because, for example, by wearing on these virtual reality glasses, the surgeon cannot see the surrounding, and you can imagine that shall not be happening in the operating theaters, because there is plenty of other people and instruments around you. And another barrier is that virtual reality or augmented reality glasses cannot be properly disinfected, not by using ozone gas or by ultraviolet or blue light radars or anything like that. You cannot autoclave those glass, meaning that when you are sterilized, dressed in the operating theaters, you cannot bring those glasses on your eyes or wear on those and continue operating. And the third part is the technology related. AR glasses today, the resolution is somehow restricted, and the viewing side is not wide enough, and it's not good enough, but it's getting better. There are already some prototypes available used for commercial purposes. And I'm confident that in next 1 or 2 years, there will be augmented reality glasses which could be weared on the operating theater while operating patient. But earlier today, Laura Holmes mentioned that solutions need to fulfill user needs. And this is where the Surgery Vision, our flagship product, comes into the picture, because annually 310 million patients are going through surgical procedures, and 50 million of those are suffering some kind of complications. For example, in US only, 4,000 patients are injured annually due to surgical failures. That's quite a significant number, especially when considering that 60% of these failures are causing temporary injury, but every third is causing a permanent injury to the patient, and even up to 7% of wrongful death. I'm sure that there is no surgeon who is willing to cause either temporary or permanent injury to their patient, not even speaking about the wrongful deaths. They are doing everything for avoiding those. And that's the reason these extended reality technologies have come into the picture, because surgeons are willing to do better planning, they're willing to perform better than they currently do, they are willing to learn and understand better the human anatomy. Currently, the extended reality solutions are used for viewing medical images like MRI or CT images. You are there, but those are a combination of hundreds and hundreds of CT slices, then merged together into one image, and then doing the planning on that. You will see an example later on today. And the image is used for planning surgical procedures very precisely. They can draw a route for the instruments, they can mark and do the drawings and annotations directly into the image, and then present those images on the wall or on the screen in the operating theater while operating the patient. These technologies are used, of course, for training surgeons, for medical students, healthcare professionals in overall, and it is really helping and supporting surgeons and clinical staff in their daily work. Now I'll try to dive in to the real patient, real image. I need to stop sharing my screen for a while and open another computer for sharing this one, for sharing virtual reality image of the human body. In the meanwhile, I'll be wearing a virtual reality glasses, like you can see from another screen here. Turn off my controllers. And this is the thorax CT of the patient. And this is the real case where you can see the tumor, for example, up here. And by the way, can you see the screen? Yes, you can. The surgeon can actually dive into the human body. They can go through the aorta very easily, just by putting head into there. They can see the human anatomy exactly as it is. Here, for example, the purchase of the aortic valve and all the structures needed. So this is how it is. It's very easy to operate. They can have a precise view of the human anatomy. They can plan the procedure, how to operate, what to operate, which kind of structures or anatomical structures to avoid, like here the vein structure to be blocked before removing the tumor. So it provides huge opportunities for surgeons to get better understanding what they are doing, how they are doing, and which kind of tasks to avoid for making those surgical failures. Then let's dive into the real world again. I stop sharing the previous screen and come back to my own. And just sharing the presentation. Let's take it from here. So the technology is in use. It is used by the university hospitals. It is used by general hospitals. And it is used by all kinds of surgical disciplines. It really helps surgeons in their daily businesses. But of course, the technology is developing further. It's not only for seeing the data or seeing the plan or doing the planning. As the next phase, it would be very important for surgeons to see below the cut, see what is coming actually. When you know what is coming below your cut, you can avoid all kinds of surgical failures. This can be done by wearing extended reality glasses, by presenting the plan on top of a patient in the operating theaters, even presenting abnormalities from the image, and then adopting that image according to patient move during the procedure. Patient position is quite frequently changed during the procedure, so the planning image in eyes of a surgeon needs to be adapted according to those moves. And even worse, it's getting worse because when touching my tissues like muscle tissues, those are moving totally different than yours. So we have to be able to adapt also on those movings and adapting image accordingly. But this is where the technology comes into the picture. We could utilize computer vision like LiDAR, camera vision, ultrasound view, or the live camera video view to the endoscopic procedure, and the augmented and the artificial intelligence as well. So in the best case, surgeons will have a view below the cut where we'll get instructions, best proposals, how to operate with certain things. But for that, we need still some technologies which are under development, not coming much common into healthcare business segment yet, but taking steps towards that. For example, artificial intelligence, it could be used for automatically presenting findings from the image. It could be automatically present and do the segmentation of those abnormalities directly from the image and creating three-dimensional models out of that. It was mentioned a couple of minutes ago that data should not be or shall not be misused. And this is where the technologies like federated learning comes into the picture, because the hospitals can teach different kind of surgical specialty abnormalities for one system by exchanging only the annotation data. Annotation means teaching of the data models, and exchanging only the data model, instead of exchanging any patient data. So system has to be secured for not changing any patient-sensitive data across the hospitals, for example. As a short summary, the extended technology has become into the surgery as well, like it has been available in other industries already for some time. It has shown to provide additional value for the surgeons and to the healthcare service providers. There are many solutions already in use and available, and more to come thanks to the many university projects ongoing, like the Erasmus project, which we are doing together with Stavanger University for understanding the 360 camera views and how that information could be utilized in the theater. Thank you, because all this is now focusing to one goal, which is our company vision, zero surgical failures.
Thank you so much, Petteri, also for taking us, as you say, below the cut with what is indeed cutting edge technology. Anita, what do you think of this?
No, I think it's incredibly, I mean, as with everything we see, it's incredibly cool. But I have a question for Petteri. Because you're dealing very much with the kind of a human-machine collaboration, right? Where we join forces. And one of the things I would hope that you could address is, because there is a tendency, and I know this with my work as well, when you provide tools to people that are very, very skilled at their work, they have a small tendency to say, well, yeah, sure, the tool is proven to be better, but like I know my stuff. My way is probably going to be better. They know their way. How do you approach that challenge?
That's a big challenge, like especially when speaking about the surgeons, that they know and understand their own value and they really appreciate their own skills highly. But luckily, in this case, the technology has shown, it has proven to make them better, because they can then execute more safer procedures. They can execute procedures in shorter time. So they are saving both time, meaning resources in the hospital, and human lives. And as a nature, the surgeons, of course, are doing their job for saving human lives. So that helps a lot.
Petteri, thank you so much for being with us and for this talk. It's going to be amazing to follow the process and the vision you have. Thank you. We've gone from the virtual to the visual and how the physical when it comes to educational technology. We'll have a look at a product that's still in the making, but was nonetheless last year awarded the most promising creative tech startup in Stavanger and a winner of the Creative tech hunt in Norway. The Dikmi building cube, or the Miller cube that it's also called after its inventor, Mai Elin Heikere, is a toy that enables children in the age 5 to 12 to learn how to read and write by combining the latest of pedagogy with the latest of technology. The Dikmi cube is combining all the technologies we've been looking at so far. It has an artificial intelligence and augmented reality controlled by GPS and numerous sensors. Still, it is tactile, gets pupils up and running, and it is a game. It is indeed playful learning that we talked about yesterday. Together with Andrew in Stavanger, we have Milla, who is a co-founder and COO of the startup Dikmi Learning. She's an entrepreneur, a designer, and a teacher with specialization in Norwegian language. And now she'll tell us the story of the Dikmi Cube.
Hi Mila, thanks for joining us today. I wanted to start by asking you about why you think language learning is so important.
Well, language is a door opener to all social and educational learning. So if you don't manage reading and writing, you will be struggling both educational and socially.
So it's clearly a key skill that all students and even adults need to make sure they have to be able to fully engage in society. So maybe you could tell us a little bit more about the Dikmi Cube and how that helps with learning languages.
Yes, I've been a teacher for many years, and I'm the mother of 4 children, and I have experienced how it is to work with and have a child that strives with reading and writing. It's really frustrating. Really demanding to be a mom home doing homework when the books were thrown in the wall. So it's no use being a teacher at a professional job when you go home and you meet this frustration. So I worked in a children's school with 6 years old, and I was going to teach them how to read and write, and everything was very theoretically. Well, yeah, we had iPads, we had good apps. Of course, we did like this station education, but we didn't have any fun building technology that was tactile. So I thought someone needs to do something with this because I saw a problem.
And when we were talking earlier before, we were talking about the fact that not all students learn in the same ways. And so I guess that's what you're trying to address a little bit with the Dikmi Cube, that students all learn in different ways.
Yes, it's a known fact that some of us learn best by seeing. Some of us learn best in the auditory way. And many of the students who struggle with reading and writing, they learn best by doing. So when they come from kindergarten, where they move around all day and they are kind of forced to sit still at their desks, they will miss their trigger learning method, right? So that's what we in Dikmi Learning me together with my co-founder Atle is trying to do with this Dikmi cube. Yes.
And do you think this is just suitable for children?
No, our goal is to start with the children, because when we developed the cube, I was working with students at the children's school in Ålgård, Solås. So the students at this school, they told me what they wanted. So the cube is developed with the children, with the students and for the students. So that's what we are trying to do. They wanted to move around, and they wanted to be active, and research and studies done actually here in Norway and abroad the world shows that when you put activity together with learning methods, it will increase the learning for all students, not only those who strives. But for adults, if you come to Norway, I've been a teacher for adults as well, learning them Norwegian language. If you come to Norway and you try to learn the Norwegian language, it's difficult. So
I can agree with that as an English person who's been in Norway for 10 years.
Yeah.
Yeah.
So we think that the cube can be adapted into adult learning as well.
Fantastic. And when we were talking before, it's much more than just about language learning, isn't it? Because we were talking a little bit about 21st century skills. Maybe you could tell us a little bit more about some of the other skills that using this cube can kind of help students to develop.
Yeah, I can. First of all, we are concentrating now on the language skills, the basic, when you work individually with the cube, because there is single player. We call it edutainment because it's yes, and you can also work together with other students, because the thought is, if I have a cube and you have a cube, and maybe the other students in the same classroom have one cube each, we want the cube to interact, and that's because when you have the basic skills of reading and writing, understanding, we believe that now in 2020, all the information is out there, right? And we have seen good examples here earlier in this session of how you can use technology and stuff. So we believe that there are 4 main skills that the students of 2020 need to develop to be able to move around in this new digital world we are living in. So we have developed a method that we call CX4, and it says something, or we want to measure how good the students are communicating, using critical thinking to solve problems, use creativity physically when they build with the cubes, and how good they are communicating. And I deeply believe, and I know, that if you master all these skills, you will be able to master the new future.
And we've been talking about many of those skills that you mentioned over the last 3 days. So I completely agree. Those are very relevant and necessary skills for students. So maybe you could tell us a little bit about, because I know you're also using AI.
Yeah,
along with the cube. Could you tell us a little bit about how AI is kind of working with the cube?
Yeah, I can. First of all, the new curriculums nationally and internationally, they focus on measurement, and they focus on depth learning, and they focus on actually on these 4 skills. So today's measurement in schools, we measure over time, but most of the tests used, in Norway we have these national tests, which well, they can be good in some ways, but if one student have a bad day, it will not give the accurate result, or where the level to the student is, right? So we use AI to be able to measure the development of one student all the time. So we will have more realistic and usable measurements. Yes.
And so you get a much more long-term picture of
exactly.
students learning rather than just that snapshot on the day of the test.
Yes, and also the Cube through AI offers each student adaptive learning from their level.
Fantastic.
And, yes, so that's important because that's really demanding as a teacher to reach each student each hour and each day. Yes.
Thanks very much, Mila. It's going to be fascinating to follow the development of the Cube over the coming months.
Thank you.
And before we go back to Tobias and Anita in Copenhagen, it's now time for us to hear from some students. Over the past few weeks, the organisation Young Entrepreneurship has been challenging school classes in the Stavanger region to look at solving a very real and current problem. The students have been asked to try to come up with a way of solving the current corona pandemic. We're going to see shortly a video with some of the ideas that the students came up with, and the competition actually ended today, so we'll also get an announcement during the video of the winning idea.
Kul måte å fremstille det på, altså presentasjonen av løsningen.
Og det har med selvberging å gjøre, så det en sånn fin kombo av flere viktige elementer som jeg tror nyttig å kunne ha.
Vi i Ungt Entreprenørskap har denne høsten arrangert innovasjonscamp for flere ungdomsskoler i regionen. Det har vi gjort sammen med Lyse, og vi har bedt elevene om å tenke seg tilbake til den tida der vi alle satt på heimekontor og heimeskole, og bedt de komme opp med gode forslag på hva som kunne ha vært gjort, eller hvordan heime kunne ha vært designet for at ting skulle ha vært litt enklere i den perioden. Hadde dette vært en mulighet, så hadde jeg i hvert fall likt det kjempegodt når jeg satt hjemme på heimekontor.
Det var veldig gjennomtenkt prosjekt. For det første så det jo enormt motiverende for elevene å få være med på å bruke sine talenter på å løse virkelige problemer. Så det enormt kjekt for de også å få lov å være med i samarbeid med næringslivet og få skikkelige utfordringer fra samfunnet. Fordi at det noe av det som vi skal jobbe enda mer med i den tiden som kommer fremover nå i forbindelse med nye læreplaner. Jobbe med innovasjon, jobbe med problemløsning og jobbe med å gi barn og unge den kompetansen som de trenger nå og i fremtiden.
Det jo en typisk en praktisk løsning på en oppgave som alle kjenner seg igjen i.
Sånn jeg synes, selv om det kanskje litt grann science fiction i på en måte hvor gjennomførbart det så har jeg veldig lyst til å stemme. Jeg synes det var veldig kjekt.
Den synes jeg var kul.
For oss det jo viktig å tenke fremtidens kompetanse, og alle de som i ungdomsskolen i dag, de fremtidige arbeidstakere. Og det et gammelt ordtak som sier at du skal tidlig krøkes for god kok og bli. Og det jo tilfellet når det gjelder innovasjon. Og vi spesielt opptatt av dette med kreativitet og problemløsning i sammen. Dette viktige egenskaper for alle fremtidige arbeidstakere hos oss. Så derfor vi med på denne konkurransen.
Ja, og det de skal ha, det at det var en veldig engasjerende presentasjon.
Så den skåret veldig høyt hos meg.
Det noe av det som fascinerte meg var denne nye valutaen med kiloskalorier som energi.
Og så synes jeg det var rørende at det også var en løsning som skulle gjøre at du hadde noe å holde på med.
Og jeg tenker når vi ser på hva disse ungdommene gjør, så når jeg en gang blir enda eldre enn jeg nå, så tenker jeg at jeg kan slappe helt av, fordi at disse ungdommene her, de kommer til å ha helt kontroll, de kommer til å løse de utfordringene vi har. De kjempeflinke.
Jeg tror vi må bare hoppe i det her, altså.
Så jeg føler hjertet mitt, så tror jeg det element inni seg, fornybar.
Så har juryen kommet frem til en beslutning. Og først og alt så må jeg få si at dette har ikke vært enkelt. Her var det mye gode løsninger, mye kreativitet, innovasjon og stort engasjement. Så tusen takk til alle elever som har vært med. Dette har vært skikkelig bra. Så har vi likevel landet på 3 stykker som kommer på pallen. Og for å begynne med tredjeplassen, så går den til en gruppe som har tatt tak i et reelt problem som vi alle har nå i disse smittevernstider. De har kombinert 2 ting som finnes fra før, og satt det sammen til et nytt produkt som jeg tror kan komme til god hjelp for oss alle. Og tredjeplassen går til Beltlight fra Bryne ungdomsskole. Andreplassen går til en gruppe som har tatt tak i et problem som jeg tror vi alle kjente oss igjen i når vi satt der på heimekontor og heimeskole. De har nå kombinert behovet vi har for underholdning med behovet vi har for å holde oss i fysisk aktivitet. Nå er det ingen foreldre som kommer til å si nei til at du skal få se mer film. Andrepremien går til Watchbike fra Revheim ungdomsskole. Nå er vi kommet til vinneren. Denne gruppa imponerte juryen. De har tenkt stort, de har tenkt bærekraftig, de har tenkt innovasjon og teknologi. Og hvem vinneren er, det får dere se nå.
Nå er vi her på Revheim skole, og vi skal gjøre noe veldig, veldig kjekt. Vi skal nemlig overraske vinnerne av årets innovasjonscamp i samarbeid med Lyse og Nordic EdTech KnowHow. Det blir veldig gøy. De har ikke peiling. De tror at de skal forklare meg den fine ideen sin. Det skal de få lov til. Men så slår vi til. Er dere klar? Kult. Hei! Så har dere lyst til å bare fortelle meg litt sånn raskt. Hva var det ideen dere gikk ut på?
Hvis vi tok oss og la på solcellepaneler som allerede finnes på en del drivhus, for å ta lyset, så kunne vi også ta, siden det er Stavanger her og det regner mye, så tenkte jeg at siden det regner, vil jeg bruke det vannet til å lage elektrisitet til drivhuset, pluss resirkulere seg et vann til å vanne plantene.
De som ikke kan gå i butikken, de kan jo dyrke maten sin der. Ja.
Hva likte dere best selv da med denne ideen?
Det kan være noe som folk kan holde på med som kan være kjekt når du ikke har noe å gjøre.
At det er på en måte fornybar, at du kan bruke det om igjen.
Og faktisk så synes vi at det er så bra innsats at vi har lyst til å overraske dere. For dere er faktisk årets vinnere av Lyses innovasjonskamp. Så her er det 10 000 kroner til klassekassen, så jeg vet ikke hva dere har lyst til å bruke den til.
Takk. Mye penger, tenker jeg. Og at vi vant, det var jo koselig.
For å være ærlig, jeg forventet ikke at dette skulle skje.
Blir det drivhus på Revheim skole nå da?
Ja.
Ja.
Yay!
Great video, and a huge congratulations both for the work and with the prize and what a lot of money to win. Congratulations from here. During the KnowHow EdTech, we've been discussing not only technology, but also methodology. We both talked about the design of curriculum and content for online courses, and we've talked about the relevance of didactics of playful learning to technology-enhanced education. Today, we'll look to computer games and the methodology of their design. It is said that the core feature of a computer game is learning. If learning is too easy, the game is boring. If the learning is too hard, you'll quit. The successful game will challenge and learn you just enough to motivate you to achieve the goal of the game. We believe that designing technology-enhanced education by artificial intelligence and adaptive technologies, we should learn from the design of a computer game. To talk to us about computer games and their design, we've got the CEO of Rainmaker Games, James Portnow. He's a game designer and consultant known for his theories on social positive design. Some will know him better as a designer on the Call of Duty games series. He has a background from the Carnegie Mellon Entertainment Technology Center. And to you, Eirik Jotten, headmaster at Revheim Junior High in Stavanger, we've got you, James Portnow, on your request. So we hope you're watching. From Seattle, we'll give you James Portnow.
Hello, everybody. I hope you are having an excellent conference so far. You'll have to forgive the background. I'm in the middle of repainting. Welcome to conferences during the pandemic. But let's jump right in, because today I want to talk to you guys about how to use games in the classroom, or more specifically, how to use the psychological techniques we've learned through making games to make the classroom a more engaging place. Because to me, we have an obligation to future generations. We owe it to the future to make school a place that every kid wants to go. Learning should be fun. If your classroom isn't more engaging for the people in it than refreshing their Facebook page, we're doing something wrong. So let's dive right in and start at the very beginning. I'll go through this quick, but let's talk about gamification and what it means. I figure most of you probably know this, but in case you don't, we've had this buzzword for about the last 10 years in the education space about gamification. This idea of adding badges or score systems or leveling trees or points and points and points and points. And you know what? It's an odd thing, but we've had these systems for a really long time. We've had badges at least since the Boy Scouts. We've had point systems since Weight Watchers or your frequent flyer miles. Skill trees have been around since the very beginning of sort of modern role-playing gaming. So that brings us to the question of why now? Why has this become a big deal in the last decade? Why has this come to the fore? And the answer is actually these guys. It may sound very silly, but Zynga, the makers of Farmville, overnight became a multi-billion-dollar corporation. It was a thing that everyone was playing, and it crossed traditional gaming lines. It made the news in the New York Times and Time Magazine, and everyone saw what they were doing. Everybody looked at this game and said, well, they're taking something fundamentally unengaging and making it something that's engaging, and not only to a traditional gamer audience. And so people looked at what they were doing there and said, how can we use those techniques in the classroom? How can we use those techniques to get kids to do their work, to learn? And the truth is that there's a problem with looking at these guys, where most modern gamification is rooted. And it's the fact that everything they did came from the research of this man, one Burhouse Skinner, or B.F. Skinner, as you may know him. For those of you guys who don't know, B.F. Skinner was the dude who put pigeons in boxes and had them press a button to get a pellet of food. He looked at the work of Pavlov and was like, wow, that's really cool. But you know what would be even cooler? If we could get something to do an act of volition, if we could condition something to do an act of volition. Because Pavlov getting dogs to salivate on command, well, that's an instinct, right? And he was like, well, yeah, maybe we can condition things, instinctual responses. Maybe those aren't things that are actually happening in the brain. But pressing a button is a choice. Can we condition something to do an action that we normally think of as a choice, as voluntary? And so he would put these pigeons in these boxes, and they'd press the button and they get a pellet of food. And over time, he would slowly take away the pellet of food. So when they pressed the button, it didn't provide the pellet of food. And he worked out a system of exactly how often you sort of have to provide that pellet of food in order to just get the pigeon to sit there and press the button all day long. And that's what these games are based on. And you know who else bases their games on this exact research? The slot machine industry. Every slot machine you've ever played, everyone you've ever seen is based on the schedules and the timetables worked out by Burhouse Skinner. But there's a problem, because kids aren't pigeons and schools are not slot machines. So we have to focus on engagement, not addiction. We don't want to get kids addicted to doing their homework. We don't care if kids do all of their math problems. What we want is for them to get engaged in doing the math, because we need them to get something out of doing those math problems. And research has shown time and time again that extrinsic rewards are not actually a valuable way to motivate people to do things, especially things that you want them to get something from in the long term. For those of you who don't know, extrinsic rewards is when you're given something outside of the activity to get you to do the activity. I pay you to do something you don't want to do, and you're going to do it for the money. You're not going to do it for the activity itself. But for schooling, for education, for learning, We want people engaged in the activity. We want people to love history, not do history because we're going to give them some candy. And there's been study after study after study, decades of research have shown the same thing, that children who expect rewards for an activity are less likely to engage in the same activity later than those who are intrinsically motivated. Seems obvious, right? But that's normal. That's what our gamification is, right? Point systems are extrinsic to the activity itself. Badges are extrinsic to the activity itself. You don't want to get the students playing for those things. So instead, let's talk about the principles of play. Let's talk about what psychological aspects of games we can take right now, this minute, and bring into our classrooms to improve our classrooms without making games, without investing any money at all. And the first one is this. Just imagine a game where you start out with 1,000,000 points. And you lose points, lose points, lose points, and lose points, and sad face, right? We would never build that game. But that's how most kids think of school. They think of themselves coming in with an A+ and just losing and losing grade over time. And if they really, really try, they can maybe tread water. But we've seen there's tons of research to show that people are more motivated watching themselves make progress rather than watching themselves fall behind. By simply upgrading up instead of down, we can give that to them. And then there's this idea that you'll see in every piece of pop film and cinema or any pop song that you've ever listened to, no matter what decade. And it's this idea of the excitement curve. I will often go into schools and teachers will ask me, how exciting should my classes be? Or I will ask them that. And when I ask them that especially, I get this almost universal response. Well, my class should be as exciting as I can possibly make it. Well, no, that's not actually true. Excitement is like candy bars. Your first one, great, right? You start eating a Snickers bar, you love it, it's awesome. But by the 20th one, you're feeling a little sick. And we found that just by putting things at the maximum excitement level doesn't actually keep people engaged. It'll get them engaged for a minute or two, but then they'll start to drop off, right? You know this. You've seen it in bad action films. That's what they do. Instead, a oscillating upward curve of excitement, and excitement can just be anything that's engaging, anything that's going to grab you, right, is sort of what we're looking for. And what's really powerful about this in the classroom is that there are these valleys built in, right? There's the unexciting moments where you have the opportunity to keep people engaged, regardless of whether or not the thing you're talking about is the most inherently engaging piece of information you can be giving them, which we have to have in a classroom setting because we're gonna have to teach those things. This right here is a graph from Star Wars. And I mean, you all know it, right? You have that starting moment where the Star Destroyer comes zooming in, you have that fight, the rebels get captured, it's super exciting. And then what you have right after? Moisture farming, right? But we care about Luke. We care about his family. We care about what's going on in his weird moisture farm and these junky droids he wants to go out and get. And why do we care? Because they've set us up with that hook, because they've built this engagement curve for us. And so if we can do that in our classrooms, if we can sort of rearrange our lesson plan with this sort of engagement curve in mind, we can keep students engaged even in the least exciting parts of our lesson plans. And then let's talk about this idea that you see a lot in sports and music and the world of art, of being in the zone, of being in that place where you are performing at your highest level and reaching new plateaus. And we have a term for it in games. We call it the flow channel. It's something that we can actually create. We've done a lot of studies about this. We often talk about being in the zone as something that just sort of happens to you, but that's not actually true. Lots of games require, in fact, depend on getting a player into that flow state. So how do we do it? Well, it sounds really simple, right? You need to keep the challenge presented to the player at a certain ratio to their skill. But skill improves over time as they do something, so challenge has to go up proportionally to that. Too much challenge and a person feels anxiety and doesn't want to do the activity. Too little boredom and doesn't want to do the activity. And that all sounds super straightforward, right? I could actually do a whole lecture on just this and exactly how you get somebody in that flow channel, how you find that space. But the short version is, I look at math textbooks. Whenever I work with schools, I look at math textbooks all the time. And I see the problems in math textbooks arranged randomly. Problem 3 might be harder than problem 5. Problem 5 might actually be the easiest problem on the whole sheet. If we simply do what we do in games and scaffold you and sort of build you up, even in our worksheets, even in our simple practice tests, all that sort of thing, if we start trying to get people to have a challenge that rises with their rising level of comfort and skill with an activity, they're more likely to enter that flow channel, break into new plateaus, and retain more, because it's a high retention space as well. And are we ever going to do it right perfectly for everybody? No, of course not. Not going to happen. But we can do it for a lot more people than we are now. So let's move on to this idea of real engagement, or why we care, because this is the most important thing to focus on. I actually think this is one of the biggest things I encounter when I talk to teachers, and it's no one's fault. It's just, unfortunately, the amount of time often given, at least in the United States, to plan and prep for your courses. Because even at the highest levels, I find that too much time is spent trying to make kids learn things, and too little time is spent thinking about why they might actually want to learn them. And if we can get kids to want to learn them, the rest flows naturally. So that's actually what we should be focused on. I was invited to teach a couple courses at this sort of experimental program to teach young women who are struggling in STEM courses, STEM, right? Science, technology, math, all that. And these were young women about, I think they were like 11 to 14, just pre-high school, right? A couple of years before high school. And they all had to sort of take this course because they were having a rough time in their sciences. And I came in, and they invited me to see if I could get them engaged. And so I came in with this big box of beads, and I just put it on the table and told everybody we're making necklaces. And everybody, all the kids got real excited because what were they expecting in the course? They were expecting a boring lecture, right, about something that they had already decided they weren't interested in and didn't care about. And all of a sudden, instead, their expectations are here, and boom, there's something more exciting to do. So they were in it, right? And once I had gotten them all, get string, get beads, grab some stuff, I sat them down and go, okay, so let me tell you, there's this tribe that has a system for how they put beads on their necklaces, right? Every year, a young woman gets to add another bead to her necklace. But there's a very specific pattern of how they build their necklaces. And I taught them this pattern, right? And then I said to them, okay, can you make a necklace for somebody who's 15? Can you make somebody who's 60? Can you make one for somebody who's your own age? And they got really excited, and they would go and do it, right? And they would go help each other, which was awesome to see. And then I pulled back the veil, and it was actually electron shells, right? And we got to do, there was a lot more because we worked with color, shape, size, we had all these variables. So we actually got to do suborbitals and all this stuff that was more complicated than you learn, at least in the States, until high school. And they got it. And I would ask them, okay, build me phosphorus, right? And they would know. I would point to the periodic table, and they would see that number on the periodic table and go, I got it, right? I understand this. I'm building that necklace. And they would put it together. And the great thing is, even there, I saw them help each other and be like, oh, no, this is how you do it. Which meant that I didn't have to teach. At this point, they had learned and were teaching each other, which was an incredible thing. And the reason they were doing it is because it was brought to them in the context of something they were inherently engaged in, rather than in the context of something they had decided or had been presented to them in such a way that they were disengaged from. But the most amazing thing about this to me was at this moment afterwards where this one young woman comes up to me and says, I'm going to take a lot more science courses. I'm like, wow, that's amazing, right? And so I asked her why. And she was like, well, I didn't ever really care about science because it was boring. Like literally she said it was boring. But this made me see that actually what science does is let you understand the beauty in the universe. I was like, right? That just blew my mind. But for her, that was it, right? She didn't care about cool logical puzzles or you being able to do more powerful things because you know science. What she cared about was the fact that this gave you an insight, a way to view even closer, more proximally, the beauty in the universe. And understanding that was the engagement point, and not this stuff that we usually think of as the engagement point around science, allowed me to then approach these students in even a more refined way. And so that's what we're looking for. We're looking for what's inherently engaging to the students about the subjects we teach. So with that, I'm almost going to leave you, but first, for those of you who are interested, let's talk about the problems that games solve if you do have the opportunity to build games or video games for your classroom. So the first one is solution, not retention. In the 21st century, the problem going forward is not how much data you can store in your head, but how you can use all the massive amount of data that we have access to in the palms of our hands with our cell phones and the internet and Wikipedia. Because today we have access to more raw data than all the libraries of the 19th century when our school system was sort of built. And so the problem has changed. But that's what games do, right? Every game you ever look at is just a set of data and a set of problems to solve with that data. Whether it's jumping over stuff with Mario or it's some building a civilization, it all boils down on a most fundamental level to that, understanding how to utilize data to solve problems. Next is iterative learning. We have this problem, at least in the States, where you get a worksheet, you go do a worksheet, a week later, boom, you get a grade back. But the problem with this is, even if you're allowed to sort of correct what you did, that amount of time means you have no idea what you were thinking when you made that mistake in the first place. Maybe doing it again, maybe doing it a week later, maybe you know more, right? Maybe you'll get it right. But that doesn't mean that you're actually learning from the mistake you made. And that sort of destroys our ability to learn iteratively. And that's one of the most powerful ways to learn, right? Next, it inculcates a fear of failure into our students by saying, you got to get this right on the first try, or mom and dad are going to be disappointed, or you're going to get a bad grade, right? That instills in students this idea that they have to be afraid of getting stuff wrong. And that's destructive. That's destructive for all of us, but especially in a modern sort of workplace environment. We are very often not looking for the perfect solution on the first try. What we're looking for is the best solution, the fastest you can find it. And the fastest you can find it often involves being willing to embrace failure and learn from it. So we shouldn't be doing that to our students. Also, we spend too much time as assessment with homework. Students probably spend 1,000 hours a year just doing homework. Imagine if we could convert half of that into learning rather than assessment, because very often we hand out homework sheets and they sort of give us as teachers an idea of whether or not the students learned what they were supposed to learn. But if that's all they're doing, we are underutilizing that time. There's so much to teach today that we need to be using those worksheets instead to be giving them more knowledge and teaching them. And that's what allowing people to fail and learn from their failures will do. In this iterative learning process, right, just real quick, every video game, this is what games are, right? Define question. How do I get across this hall? Gather information. There's an enemy here, here, and here. Form hypothesis. I run across this way. Test hypothesis. I run that way. Analyze data. I got shot. Interpret data. That was not the correct way to get across the room. Publish results. Press continue. Retest, right? And that cycle is taught through every single game. You'll see people do it, right? You'll see people do that cycle, learn, and go, oh, maybe I should take cover, right? And get through. It also, games allow us to tailor lessons in a way that we aren't able to in our classroom. I was teaching at the college level, and even there, even with small classes, I knew that I wasn't able to make the best possible lesson plan for every single student. I just had to create the best I could for as many people as I could. But games can actually tailor, through something called context-sensitive information, the lesson and the information provided to every student. This thing you're seeing, pull right trigger to fire from the hip, doesn't actually appear here unless you need it. If you run here, shoot these things, and run on, well, great. right? You already know that lesson. We don't have to tell you anything. But if you stand here for a second and you aren't doing the right thing, all of a sudden on your screen will pop up this message. We can do that with anything. We can even do it with different learning styles, right? We can try different learning approaches if within the context of a game, a student fails an activity. And of course, we can give feedback to the teacher and say, hey, we tried this, this, and this, and the student was still unable to get past this activity. Maybe you should have some one-on-one time with them. Finally, 21st century skills. I don't know if you guys have heard of these, but in the United States, there was this big survey done early in the 21st century saying, what do people need to become effective citizens and workers in the 21st century? It was critical thinking, communication, collaboration, creativity. Well, I can't think of 4 skills that are more often used in games, right? Critical thinking, any puzzle game you ever see. Communication, every multiplayer competitive game that's team-based is based around communication. The team which communicates worse loses. Collaborative games, there are tons of games where you cannot actually progress without working together. And finally, creativity, well, we can teach creativity in games. We can actually improve people's creativity. You give somebody Minecraft and at first they're just going to build little blocky nothing structures. And a year or two later, having had this canvas, having had a place where it's safe to be creative and to fail, to be creative and make things that are ugly and stupid and terrible, and even you hate, right? And then to smash them down and build whatever again, or try and build better, allows them to improve at creativity. This thing that we've always considered unteachable is teachable through games. And finally, there's that smallest thing, which is the idea of agency. I was working with this class in Oakland, and the school was not the greatest school, not to the fault of any of the teachers. Everyone who was working there was trying super hard. The kids were great, but it was the sort of place where you didn't go to college, where pregnancy just happened, where one day I had this kid who said to me, I couldn't do my homework because I was hiding in the bathtub because people were shooting outside. And I came in, I was invited there with some friends of mine who were teaching there early in their teaching careers, and I was going to teach the kids the scientific method using Super Mario Brothers. And so I was invited in, I came in, I started teaching this, and I watched this kid play. And he runs and he jumps and he falls in a pit. And he runs and he jumps and he falls in a pit. He runs and he jumps and he tries something different, and he gets to the other side. And it didn't kick the door wide open, but it started this conversation. We talked about the fact that that was his life, that there was some path, some set of choices he could make that would allow him to go to college, would allow him to get the things he wanted out of life. And that sense of agency is important. That sense that you control your own destiny is something that schools have to bring, because to me, there are 2 things we're trying to do with schools. 1, inculcate a lifelong love of learning, and 2, provide you with the tools to get the life you want. And you can't do that unless you believe you have control over your own destiny, which is something that games are really good at teaching. So with that, I will leave off and ask you for your thoughts. I may have to...
Thank you so much to James. It's kind of a scoop to have a gaming superstar like that on video here. Yep. Well, of course, he's talking about how we can be inspired by game-based learning, and he talks about the Flow channel, 21st century learning skills and all that. It's good. And I truly believe that we can be inspired both by play and games. But sometimes I guess also education and the learning process is also slow, it's long-term, it's very hard for kids. And it requires focus, it requires judgment from them. Can games, computer games and artificial intelligence play a role there in that aspect?
I mean, I think so, absolutely. I mean, I think, and one of the things that I really liked about his talk as well is bringing in that long perspective, because a lot of times when we talk about games and game theory and gaming, we think about these like quick, small, phone games that gives like instant gratification and every, but like if you watch a kid that's like playing a game, like a strategy game or something where you can watch them sit for like hours and hours and hours without really any big reward, until the very end. And so I think that patience and that like resilience, like I think you can build that into education through game design, game thinking as well. So I think it's super interesting.
Yeah, and it's definitely something you have to be aware of when we're trying to kind of get inspired from the game-based world.
Absolutely.
Great. We started KnowHow EdTech looking back on the digital transition education had to go to overnight when schools and universities were locked down. During this week, the Nordic Edge and the KnowHow EdTech and Microsoft, together with Nordic Edge in Oasis, have organized a digital hackathon on the topic Reinventing Education. Let's see how the participating students envision education.
Imagine how far education can take you. All around the world, people are thinking about how education can be improved. What happens if these people are connected to collaborate? It is time to rethink education.
This week, Microsoft for Startups, the University of Stavanger, and Nordic Edge in Oasis hosted a digital hackathon called Reinventing Education.
A hackathon is usually a 24 to a 48-hour long competition.
For 34 hours straight, people around the globe was working in groups across time zones with people they've only met virtually and never before in their life.
It's been amazing.
And you won't believe how far these innovators came in just 1.5 days. We've had teams developing concepts within artificial reality, intuitive math education, learning by moving, prediction models for school dropouts, and many, many other subjects.
Let us dig into the details.
Why is innovation in education so important?
Definition of our future are in the hands of today's students and today's creative younger people. How we would like to see our future, they define it.
All kinds of innovators, students, programmers, marketers, teachers, and others came together virtually to create the future of how we learn.
We saw a drastic change in the way we need to teach the students and the way how we evaluate them. And a lot of the digital tools, they worked really well, but we also saw that we need some improvement to these tools to go into the future.
We've had people from Denmark, Sweden, the UK, Indonesia, India, Belgium, the Netherlands, Ireland, the US, Ukraine, and of course, Finland.
I have smaller children, Carl, and let me just try to describe what happened to them in March. They took the technology, the new way of learning, like that. I think the challenges was all in the back office. Everybody else, we were not aware of that. Fun fact is that what our industry, the ICT industry, had been spending decades on, that happened in 3 weeks. Just over the night, basically. We were not dressed up for this.
It is time to reveal the winner. And the winner is me. Elon Musk was right. AI is coming. Did you think Carl was in charge? No. I am just kidding. This is the jury. The winner is Team Focus Live. Congratulations.
Team Focus Live won the hackathon by developing a genius and a bit controversial concept for providing live feedback to the teachers on how well the students are focusing in a digital classroom by using eye detection and machine learning.
Hello, we are Team Focus Live. Our team consists of Paul Williams and Ajit Rajasekara Pillai, both from Norway, and Svetlana Pustova-Serebryakova from Ukraine. We first met on Monday at the hackathon Reinventing Education. Together, as a team, we discussed helping distance learning pupils, even those reluctant to ask for help, to feel in control of their learning process and give them the possibility to provide feedback. Faculty in both K-12 education and adult education have taken the challenge of shifting to digital-focused education with open arms. However, for most, if not all educators, a big question remains open. Did my students understand the task?
That's how the idea for Focus Live emerged.
Focus Live is a multi-platform solution for stakeholders in education. The concept is that the eye tracking technology helps get the learners live feedback, show attentiveness on the task, or supply materials cognitive load.
The live feedback is anonymized, aggregated, or combined feedback created using eye tracking and body language detection. The system collects the data and analyzes how much a student is focusing on a particular material. This way, after aggregating the data, the AI part could predict whether the presented material is easy to understand or not. The teacher then can follow and improve the material, thus helping the learners achieve their goals. Therefore, we could supposedly reduce dropouts by providing better structured information.
The prize for winning was 10,000 Norwegian crowns, support from experts in Microsoft, and the possibility to display the solution in a Microsoft Technology Center. Hopefully, this will provide the boost they need to take the concept out in the world.
Very interesting to see. Well, Andrew, what do you think of this?
I think it's fascinating, but I think like many of the other applications we've seen of AI and machine learning, I can see a potential for misuse, with some of this. And yeah, I think it's very important that we use all this technology in a really positive way.
Yeah, we've been going back and forth in that paradox and that dilemma all day. Anita, what do you think about it?
I think that's going to be. I don't think there's any AI projects where that isn't going to be one of the things that we have to consider. But we'll get to that in a few minutes as well.
Oh yes, we sure will. Anita, we're coming to the end of the KnowHow EdTech 2020 in what was and is a very remarkable year. We've been talking about future technologies. We've seen things that I didn't imagine I would see today. From your perspective and the way you see things, what's your reflections and takeaways from today?
It's been an incredibly interesting day. A lot of really cool use cases, and I think the main reflection I'm sitting on is this idea that everything we've seen today, all of the examples, all of the use cases, keep in mind when you see them that like this is the worst this technology is ever going to be. Right? It's only going to be remarkably much better from here. That's the first thing to consider. Like everything you see is terrible and it's going to get ridiculously much better over the years. That can sometimes be a little intimidating. There's a lot of new technology. There's so many we have, a dozen different Gutenberg moments all at the same time. It can be intimidating. It can be overwhelming. But keep in mind that the really cool thing about our brains and how human beings work is that we adapt to new technology ridiculously fast, right? So if you think back to, 2000 and then, 20 years forward. We have more power in our pockets right now than the US government had under the moon landing, right? And that is natural to us. It's part of how we operate. So the moment we start adopting and using new technology, well, suddenly it's the most natural thing in the world. Of course, we have a supercomputer in our pocket, right? Who doesn't? And so that's the first thing to remember, that we are adaptable mammals that can utilize new technology really well. So that's the first thing to keep in mind. I think when it comes to AI specifically, we have to always consider the ethical implications. And we've touched on that many times today. Much like any other tool, right? The first time a human being picked up a rock and decided, what to do with it, that human being could decide to, smash a nut to get some better food, or to smash someone's head to win a partner or win an argument. So we humans, we always have to decide, how do we want to use the tools that are available to us? When it comes to artificial intelligence, though, there is an extra added layer of complexity, which is, most companies building AI systems, they're not evil by design, right? They're not like, I'm going to build a system that's really racist or really, sexist. Most kind of evil or mistakes happen in what I would call evil by, oh, I didn't think that far. Right? And so we have all these ethics concerns around, not just the real versus fake videos that we saw initially, from Synthesia, but also data bias, right? The data sets that we choose are always going to guide the outcomes of the algorithms that we use, right? So to take an example from our company, because we talk a lot about personal data and it's easy to see the conflicts there, but even in data sets that are seemingly straightforward. So what my company does is that we, in short, Long term is we're building an AI researcher. Short term, we've built some really neat tools for academics and industry researchers to do literature reviews. So navigating knowledge. You know, one of the things we had to consider from the start was we have this great system already in place with plenty of data, the citation system. The citation system is great. It's just really, really biased and essentially becoming a popularity contest, if you will. And I know that's simplifying things. So we had to make a decision early on. Do we want to use that and embed all the biases in that system? Or do we want to take on the much more challenging task of building an engine that can actually understand the content of the papers and do literature reviews on the actual content? And when we chose the latter for ethical reasons. Another thing to consider, right, if all of this data we use is built on the past, sometimes the past was really terrible. Right? So you have this example, which is the classic example of a Google job ad algorithm that had executive job ads, and they had these bots going in and just measuring how often these job ads were shown. There were some Carnegie Mellon researchers doing this, and they found that these executive job ads were shown to men 1,800 something times and to women 300 times. That's going to be a problem, right? The problem is that that is statistically accurate. Like the data shows that that is the case, and the machine learns from the data. There aren't enough female CEOs in the world, and so we have this data issue where you know, if we predict the past, predict the future based on the past, well, guess what? We're going to repeat the same mistakes. Another thing that I want to touch on is this, you know, idea sometimes that that people have when they hear about AI and robots is that, well, is the robot going to take my job? Like, do we not need teachers in the future? Do we not need educational professionals? And you know, there's a couple of aspects to it. One is, I personally don't believe that a 9-to-5 job is the ultimate human experience. You know, we should think about it maybe not as much as, is it going to take away my financial situation, but is it, is it going to enable me to live a fuller life? However, what I want to say as well is this, right? We are going, I mean, teachers and educational professionals is one of those fields where we are going to need a lot of human interactions, right? Teachers doing what they are good at, while the AIs and the machines can do what they are good at. So what you have right now is an opportunity for teachers to get involved, to be part of this, and to be part of this movement, right? And what we have to teach our children is, as you know, we heard about in the game theory section earlier, we have to teach our children creativity, communication, critical thinking, right? And critical thinking is definitely important when it comes to these algorithms and the software and the AI that we're going to be using. Complex problem solving, and finally, the thing where I think it's going to be a long time before our AI systems can do this, and maybe the most important, which is empathy, which is human connection. And I think teachers are going to have an incredibly important role in allowing our kids to keep having that human connection, while the AI can do a lot of that boring work that the teachers don't necessarily love anyway. So I think, there's so many opportunities in the future. We have to do it right. We have to consider the ethics. And I think there is a role to play for every single one of the listeners today in shaping that future and having a voice and being part of it.
So also focusing on the human factor still, I'm happy to hear, and I was a little worried about this, that the AI is not going to take over the job as an educator or a teacher. Still, I'd like to hear you, just to end things with reflections here, the way you see it, what role could technology play then in education?
So I think technology will be part of every step of the educational process, right? From the kind of personalized follow-ups, an AI system that knows you as a student, as a human being, knows what you've learned, knows how you'll learn best, all the way to the boring administrative tasks, filling out paperwork, handing in your receipt for, all of those things. Like it's in every single part of the process. And some of these processes will also radically change. Some of it will stay the same as it is now, but just enhanced with technology. So I don't think there's any area, maybe except the human connection, face to face, eye to eye, Although in these COVID times, screen to screen, and suddenly we're back to technology being part of it.
It's been a pleasure having you here with me in the studio in Copenhagen. Thank you so much.
Likewise, thank you for having me.
And thank you also to Andrew and the crew at the University of Stavanger. We've come to an end of KnowHow EdTech 2020. Hope you got some new ideas and insights on educational technology. Stay in touch with us on Facebook and on our website, where you'll also get the recordings of the conference. Now, for 3 days, we've spoken enthusiastically on how to keep schools and work going online. Nonetheless, we should also know how to make ourselves digitally invisible and unavailable. Before we end today, we'll tell you how to get offline, log off, take a break, have a nice weekend. And from me, thank you so much for participating. This is Elizabeth Armstrong, who is an advisor in the Digital Task Force at the University of Stavanger.
Hey, in this video, I'm going to show you how to limit the tracking of your mobile phone. Now I'm going to show you where you can find what apps are accessing your device location. I'll be doing this on an Android phone, but you can also do this on an iPhone. The first thing you need to do is find the settings menu. It could be in the main menu as you see here, or it could be in the drop-down menu. It depends on your phone. While inside here, you'll want to look for the location tab. When you open this up, the second option will be app permissions. By entering this, you'll be given a list of all the apps that are running in the background collecting your device's location information. You may be a little bit surprised to see how many apps are doing this without you ever knowing it. You can press onto any one of these apps, and you will then be given the option to restrict or deny access to the location information. By pressing deny, you will see that the app disappears from the list and is no longer collecting your device's location information. You can go through the list and do this with all of the apps that you feel don't need to have your location. And that was that. You can now go about your day with a little bit more privacy.